We're now going to continue our discussion of solving inequalities, but now we're going to look at inequalities that have an absolute value in them. So before we begin, just a few things that we want to remember. Remember, as you're solving inequalities, your goal is to solve for x. Remember that if you multiply or divide by a negative at any point, you need to change the direction of the inequality. And then finally, if you have a less than inequality with an absolute value, you want to write a combined or three-part inequality. And if you have a greater than inequality with an absolute value, you want to write two separate inequalities. So this is important because as you begin working a problem, you need to look at whether or not you have a less than or a greater than to help you determine how to get started. So let's begin with an example. We have the absolute value of 2x minus 5 is greater than or equal to 3. And so as you recall, for a greater than inequality, our goal is to write two separate inequalities. So what we're going to do is we're going to write an inequality that looks almost identical to the original problem, except it doesn't have the absolute value. So I'm not going to make any changes to the first inequality, except that I'm going to take the absolute values off. For the second inequality, and this mimics what we did on the equations with the absolute values. As you recall, we set up one equation where it was equal to the positive number, and then we set up a second equation where it was equal to the negative. We're going to do that same thing here. So our second inequality is going to have 2x minus 5. And instead of a positive 3, we're going to introduce a negative 3. Remember that our rule says that if at any point we bring a negative into the problem, we want to change the direction of the inequality. So on this second inequality, I'm going to make it less than or equal to. So you want to keep in mind that over here on the second problem, that you are making two changes. You're putting a negative on the right-hand side, and you're also switching the inequality. So once that is set up, then we're ready to solve the two problems. So remember that our goal is to get x by itself. So I'm going to begin by adding 5 to both sides of this expression. So that's going to give me 2x is greater than or equal to 8. And then solving for x, I would need to divide by 2. And so x is greater than or equal to 4. And that solves the first inequality. For the second inequality, I'm also going to add 5 to both sides in an effort to get the x by itself. So this gives me 2x is less than or equal to positive 2. I'm then going to divide both sides by 2, which is going to give me x is less than or equal to 1. Now remember that we want to write our final answer in interval notation and also display it on a number line. So on the number line, we're going to put the 1 and also the 4. Because the 4 is included in the solution set, so I have the equal to there, I'm going to use a solid circle on the 4. And then I'm going to shade x values that are greater than or equal to 4. So numbers greater than 4 are going to go to the right. We'll color in that arrow, meaning that we're going to continue all the way to infinity. For our other problem, we have x is less than or equal to 1. And again, since 1 is included in the answer set, we're going to use a closed circle. We want x values that are less than 1, so that's going to also shade to the outside. And so our number line will look like that. Now for our interval notation, we're going to write two separate intervals and combine them with a U, which stands for union. So on the left-hand side, if we look at where we begin shading, we begin shading at negative infinity, and we shade all the way to 1. Remember that an infinity always gets a parenthesis, and a closed circle is going to translate into a bracket. For our other side, we're going to do the same type thing. We're going to say that we begin shading at 4, and we end shading this one at positive infinity. We're going to work from left to right. Infinity always gets a parenthesis. The solid circle on the 4 translates to a bracket. And again, we're going to use a U in between to stand for union to say that both of those intervals represent solutions to the original problem. Let's try another one. So this one has the absolute value of 2x plus 4 is less than 3. And if I look back at my rules, I can see that if I have a less than inequality with an absolute value, I'm supposed to write a combined inequality or a 3-part inequality. So what I'm going to do here is I'm going to have the 2x plus 4. I'm going to take it out of the absolute values, and I'm going to sort of sandwich it in between the positive 3 as it was and also a negative 3. So on a less than absolute value inequality, you're going to take the part of the expression that's inside the absolute value, and you're going to place it in between the positive and the negative part of the number. And then your goal, as we solved in the last section, is to get x by itself. So we'll start by subtracting 4. Remember, when you subtract 4 from one part, you need to subtract 4 from all parts. So negative 3 minus 4 is going to give me negative 7. Less than, we're left with the 2x in the middle. And 3 minus 4 is negative 1. Then we need to divide by 2. And again, we'll do that to all 3 parts. So our final answer is going to look like negative 7/2 is less than x is less than negative 1/2. So when we do our number line, we'll mark off the negative 7/2, and we'll mark off the negative 1/2. Note that neither number is actually included in the answer set because there is not an equal to underneath the two less thans. So what that tells me is that I'm going to use open circles on the 7/2 and the 1/2. Remember that we shade in between because the x is actually located in between the two numbers. And then when we write our interval notation, we note that we start shading at negative 7/2. The shading stops at negative 1/2. And because neither of those numbers is actually included in the solution set, we're going to use parentheses. Our final example is different in the sense that it has a number in front of the absolute value. So when we are solving absolute value equations, it is most helpful to have the absolute value by itself on one side of the equation. So before I worry about trying to figure out if I'm going to write a combined inequality or separate it into two problems, the first thing I'm going to do is get rid of that negative 4. And I note that the negative 4 is multiplied on to the absolute value, so I know that to get rid of it, to undo it, I'm going to divide both sides by negative 4. So that's going to cause those negative 4's to cancel on the left, and it's just going to leave me the absolute value. (12) divided by negative 4 is going to be negative 3 on the right. And remember that because we divided by a negative, the rule is to change the direction of the inequality. So that greater than now becomes a less than. So this is the problem that we're going to work with. And as we look at that problem, we note that it is a less than problem. So again, a less than problem, we want to write a combined inequality. So I'm going to take the x plus 11 and I'm going to put it in between the negative 3 and the positive 3. And at that point, you might begin to notice that we have an issue or a problem with this particular problem. Let's come back up to this part right here. What do we know about an absolute value problem? We know that an absolute value of anything will always be positive. Now, why is it important for me to note that? Because what this problem is asking me to do is to find x values where the absolute value is going to be less than a negative number. And we know that that is not going to be possible. If the absolute value, if this part of the problem is always positive, we're never going to have a positive number be less than negative 3. And so because of that, we don't actually have to work this one out. We can simply say that there is no solution to this absolute value problem.